Hello everyone, myself Muskan. I am a student of BSc Chemistry Honors first year in Pandit Nekiram College. Today I will discuss organic chemistry chapter S block. Let's start our chapter. S block elements. The elements of group 1 and group 2 of the periodic table constitute the S block element. These two groups are called S block element as the last electron goes to the S subshell. Generally the configuration is noble gas NS12. The element of both group are light and heavy, highly reactive. Let's discuss the electronic configuration. Lithium has atomic number 3. Its electronic configuration is 1s2 2s1. Then sodium, its atomic number is 11. Its electronic configuration is 1s2 2s2 2p6 3s1. Now potassium has atomic number 19. Its electronic configuration is 1s2 2s2 2p6 3s2 3p6 4s1. Now then we come rubidium come after that cesium and then francium. Francium is a radioactive element. The element of group 1 are highly reactive and form strongly alkyne oxide and hydroxide. Therefore, they are called alkali metal. Francium is a radioactive metal. The element of group 2 are called earth metal since they are alkaline in nature and existed in earth. Radium is a radioactive metal. General characteristics of alkali metal. All the elements of group 1 are silvery white soft light metals. They have simpler chemistry than any of the other group in periodic table. These have an electron in their valence shell to form univalent ionic or colorless compound. Now we will discuss the properties, which is density. Density of the alkali metal is quite low. Lithium, sodium, potassium are lighter than water, even though the element have close packing of metal atoms. But because of large size of alkali metals, they have low density. Density increase down the group top to bottom. Potassium is lighter than sodium. This is due to its large atomic volume. Now next will come atomic and ionic radii. Atomic and ionic radii of alkali metals are the largest in their periods. From to top to bottom, the atomic or ionic radii increase in the group. The size increase because the number of subshell of electron increase from one element to another in the group. As the number of shell of electron increasing, shielding effect also increasing, effective nuclear charge decreases, the outer shall expand further. Now we'll discuss ionization energy. Alkali metals have the lowest ionization energy in their respective period. In a group, the ionization energy decrease from top to bottom. This is because the atom have large size. There is only one electron in its valence shell. By losing one electron, they acquire more stable noble gas configuration. The second ionization energy, that is EI2, of alkali metal is very high. This is because of two reasons. After losing one electron, atom changes into cation, which is a highly effective nucleus charge. Cation of alkali metal have noble gas configuration, which is very stable. Now we will discuss melting point and boiling point. All the alkali metals are soft and have high melting and boiling point. This is because they have only one valence electron per metal atom. Therefore, the energy binding to the atom is in the crystal lattice of the metal is comparatively low. The melting point of lithium is 180 degrees Celsius, while cesium melt at 28.7 degrees Celsius. Thus, melting point and boiling point decrease down the group. Now we will discuss electropositive or metallic character. The tendency to lose the electron and acquire positive charge is called electropositive character and metallic character. All alkali metals are strongly electropositive. That is shown in this. M is here metal which lose its electron and get positive charge. Electropositive character is related to ionization energy. Since ionization energy of alkali metals are low, these have high electropositive character. As ionization energy decrease down the group, electropositive or metallic character increase from top to bottom in the group. Now, oxidation state. The alkali metals have one electron in the outermost shell. All alkali metals lose this loosely bound this by this electron and show +1 oxidation state in the compound. After losing one electron, monovalent ion M positive will the noble gas configuration are formed. The second ionization energy are very high due to the stable configuration after losing one electron. Therefore, alkali metals show +1 oxidation state in their compound. Now we will discuss photoelectric effect. The phenomena of ejection of electron from a surface of metal when light is of suitable frequency strike on it is called photoelectric effect. As they have low ionization energy, cesium has the lowest ionization energy. Therefore, it show maximum photoelectronic effect. These metals are used largely in photoelectric cell. Now we will discuss characteristics flame coloration. The alkali metal imparts characteristic colors of flame. The alkali metals have largest size in their respective period. Hence, they have excess low ionization energy. When the alkali metal or their salt are heated in the Bunsen flame, the energy provided by the flame is sufficient to excite the electron to the higher energy level. The excited state are unstable and electron tends to come back to the ground state. When the electron return to the ground state, the excess of energy is released in the form of flame coloration, which lies in the visible region of the spectrum. The alkali metals and their flame color as shown. Lithium show crimson red, sodium show golden yellow, potassium show violet color, rubidium also show violet color, and cesium also show violet color. Now we will discuss lattice energy. It is defined as the amount of energy released with 1 mole of ionic solid is broken into a constituent ions. The solid of alkali metal are pure in ionic nature, consist of cation and anion held together by electrostatic force of attraction. Therefore, lattice energy of alkali metals salt is very high. Lattice energy is measured by force of attraction between the ions. It depends upon the size and the charge of ion. Since charge on the cation of alkali metal is same, the lattice energy of salt for same anion decrease with increase the size of cation. This is due to the decrease in the force of attraction between the ions, as shown in this table. Now we will discuss basic characteristic. Hydroxide of alkali metal are most basic in nature. The basic character increase down the group. The reason behind this, alkali metals have larger sign in their periodic respective period, therefore they have less ionization energy. The MOH bond is ionized due to large size of alkali metal to M positive and OH negative ion. As the size increase down the group, the ionization energy and the basic character increase down the group. NaOH is stronger base than LiOH and KOH is stronger as compared to NaOH. Chemical properties. Now we will discuss their chemical properties. The alkali metal are highly reactive due to their large size, low ionization energy and heat of atomization. The important chemical property and their trends are as follow. Firstly, we will discuss action with air. All alkali metal tarnish rapidly on exposure to air due to the formation of oxide at the surface. The oxide may further react with CO2 and moisture to layer of carbonate at the surface. There are therefore stored under kerosene to protect them from air and moisture. The alkali metal burn vigorously in air, forming three type of oxide: normal oxide with O2 negative ion, peroxide having O2 negative ion, and superoxide containing O2 negative ion. The product depend upon the nature of metal. Now we will discuss lithium. Lithium form only simple oxide. Then sodium form peroxide. Potassium, rubidium and cesium form superoxide. They are explained on the basis of the size of cation and anion. Smaller the size of the cation stabilize smaller anion. Large cation can stabilize larger anion. Now lithium ion has smaller and therefore it stabilizes small ion. Because of strong positive field around lithium positive, it prevent the spreading of negative field towards other oxygen atom. Therefore it cannot attack other O atom. Higher oxide cannot be formed. Na positive is large in size and can stabilize large anion. The potassium, rubidium and cesium are still larger cation, have weak positive field which allow the formation of superoxide ion. Now we will discuss action with water. Alkali metal rapidly and readily react with water, forming hydroxide and liberating H2 gas. Lithium can react slowly, but reactivity increase from lithium to cesium. For potassium, rubidium and cesium, the reaction is so fast that evolved H2O catches fire. So these are kept under kerosene. Now we will discuss action with hydrogen. The alkali metal react with hydrogen to form hydrides. Firstly, ionic character hydride increase down the group. Reactivity of a hydride increase down the group. Stability of the hydride increase down the group. All hydride are strong reducing agent. Now we will discuss solution in liquid ammonia. Alkali metal dissolved in ammonia to give blue solution. The ammonia molecule solvated the cation as well as the electron. The value of X and Y depend upon the extent of solvation of cation and electron. The ammoniated electron is responsible for blue color of the solution. The solution is paramagnetic due to the presence of free electron. These solutions are strongly reducing agent. These solution can reduce aerially oxygen to superoxide and peroxide. On standing a long duration, the solution liberate H2, reducing nature and oxidizing potential. The alkali metals are strong reducing agent. This is because of their low ionization energy. Their reducing nature is indicated by the large negative value of their reduction potential, that is high oxidation potential. Lithium energy as the strong emerges as the strong reducing agent through its ionization energy is among all the alkali is very high. This can be explained if we recall the ionization properties of the alkali metal in the gaseous state. Oxidation is a property of metal goes into solution. The oxidation potential is a tendency for overall change which depend upon the net effect of all three steps. Since Li positive has the smallest size, so it is hydrated to maximum extent. The large hydration energy of lithium positive ion compensate the high energy needed to remove the electron in the second step. The lithium is the strongest reducing agent because of their greater hydration enthalpy. Now the question arises, how does lithium differ from the other member of the family, or other, in other words we can say, show how lithium show anomalous behavior. Due to the small size and high polarizing power, lithium differ from other alkyl metal in the following respect. First one, lithium is much harder than the other alkyl metals. Its melting boiling point are also higher. It is less reactive in all alkali metal. Lithium is only the alkali metal which react with nitrogen to give Li3N. Lithium burn with oxygen and form monoxide Li2O, while other member form peroxide and superoxide. Lithium react with bromine slowly, while other alkali metals react violently. Lithium carbonate is thermally less stable than carbonate of other alkali metal. LiOH is much weaker base than NaOH and KOH. Fluoride, phosphate, oxalate, and carbonate of the lithium springly soluble in water, while the similar salt of sodium and potassium are highly soluble in water. Lithium chloride and nitride are soluble in alcohol, whereas the corresponding salt of sodium are soluble in water. LiH, so lithium hydride is more stable than the hydride of other alkali metal. Li positive is extensively hydrated. Degree of hydration decrease from Li positive to Cs negative. On heating, LiNO3, nitrogen dioxide and oxygen evolved. Diagonally relationship. Now we will discuss that topic, diagonal relationship. Though lithium differ from other member of its own group, it resemble with the magnesium, the second element of the group 2. This is called diagonal relationship, in which the first member of the group 1 show the similarities with the second element of the next group on the right in the periodic table. Cause of the diagonal relationship. The cause of diagonal relationship are similar electropositive nature. On moving left to right, the ionization energy increase. The electropositive character decrease in the period. But on moving down the group, the ionization energy decrease, electropositive character increase. Thus, we move diagonally. The metals have same tendency to each other. As a result, lithium and magnesium has almost the same electropositive character. The second reason is similarly polarizing power. From left to right in the period, the ionic charge increase with the decrease in the size. This increase the polarizing power. But from top to bottom in the group, when we move diagonally, these two effect partly balanced each other. The polarizing power of lithium and magnesium remains almost the same. Diagonal relationship between lithium and magnesium. Lithium and magnesium resemble in the most of the aspect. The common feature of these elements are as follow. The atomic radius of lithium is 1.34 Armstrong, while that of magnesium is 1.36 Armstrong, which is not very different from each other. The ionic radii of lithium, that is 0.68 Armstrong, is similar to ionic radii of Mg2 positive, which is 0.65 Armstrong. The polarizing power of the two is about the same. Both of them form monoxide. Lithium form monoxide and magnesium also form monoxide. Lithium and magnesium both decompose water slowly, liberating H2. Both of them form nitride on heating with the nitrogen. Carbonate of both give oxide on heating. LiCl and MgCl2 is diliquescent, absorb moisture or exposure to air. LiOH and MgOH is a weak base. Both lithium and magnesium are quite hard in nature. Now we will discuss about the properties or something about the group 2 elements. General characteristic of group 2 element. The various physical constant of alkyne earth metal are given as atomic number, atomic mass, atomic radius, ionic radius, and ionization enthalpy energy and oxidation energy.